In this video, we consider three examples of integration by parts. In the first example, both functions can be integrated. In the second function, only one of the functions can be integrated. And in the third example, there's only one function and it cannot be integrated. Let's take the first example. Here we will integrate the function e to the x because this function x, when differentiated, gives a much simpler function in the sense that derivative of x is 1. But if we were to integrate x, the function returned by this on integration is x squared over 2, which is a little more complicated or a little more complex than this. So by integration by parts, this is integrate e to the x multiply by the other function minus integral ex dx, and write down the derivative of this function. So this becomes x times e to the x minus e to the x dx, which is x times e to the x minus e to the x plus a constant. The second example is x to the tangent inverse x dx. Here, this function can be integrated, and this one, tangent inverse x, cannot be integrated. Therefore, we have no choice except to use the formula where we integrate x and differentiate tangent inverse. So this is x squared over 2 tangent inverse x minus integral of x squared over 2 times 1 over 1 plus x squared dx. This is x squared over 2 tangent inverse x minus 1/2. X squared over 1 plus x squared can be written as 1 minus 1 over 1 plus x squared. This is x squared over 2 tangent x inverse x minus 1/2. Integral of 1 is x, and integral of 1 over 1 plus x squared is tangent inverse x plus a constant. The third example is integral of ln x dx. Now to find this integral, we see that ln x is only one function. Therefore, we write it as, in a logical way, we write it as a product of 1 times ln x dx, so that now this is treated as product of two functions. Ln of x cannot be integrated. That's why we have to go through this process, and therefore we have no choice except to use 1 as a function for integration. in the formula for integration by parts. And so this is by integration by parts is integral 1 dx times ln of x minus integral 1 dx times the derivative of ln of x dx. This is x ln x minus integral x times 1 over x dx. X times x and 1 over x cancel out, and so this is x ln x integral of 1 is x plus a constant. Therefore, this gives us the integral of ln of x. We can, however, write it as x times ln of x over e plus a constant, or let me simply write this as x ln x over e plus a constant, because ln of x over e is ln of x minus ln of e, which is ln of x minus 1.